Today we will discuss theorem 10.2 circle chapter class 10th. Okay, before that we will just go through these diagrams. That is circle where point P is inside the circle. There is a circle, point P on the circle. This is also a circle, point P outside the circle. Okay, now when the point P is inside, you can have so many lines drawn, but all the lines will intersect the circle at two different points. Okay, so here these lines can be act as a secant, so no tangent possible. When point is inside the circle, no tangent possible. Okay, when point P is on the circle, you can have one tangent. When point is on the circle, then only one tangent is possible. Now when your point is outside of the P, then you can have at the most two tangents, minimum one tangent, at the most two tangents is possible. Here the point P and the point of contact, this length PT1, here PT2 are called the length of the tangent. Okay, so when point is outside of the circle, two tangents are possible. Okay, these information we will utilize in solving the problems of the exercises. Okay, now come to theorem 10.2. Now theorem 10.2 says that the length of the tangents drawn from an external point to the circle are equal. Means, just go through this figure. Length of the tangent drawn from the outside point PT1 and PT2 are equal. You have to prove this. Okay, now let us see how to prove it. So we will make a diagram. There is a circle, there is outside point P. Circle will have center O, point of contact is T and R, so PT and PR are the tangents. Okay, so just write it. Given a circle with center O and a point P outside the circle and two tangents PT and PR, where T and R are point of the contacts. Okay, now we have to prove PT equal to PR. This PT and this is PR. Construction, if we require, so here we require joining O to T, O to P and O to R. So I have written we join O to P, O to T and O to R. Okay, now come to the proof part. How will you prove this? Now you can see that this triangle OTP and ORP are the which type of triangle? This is a right angle triangle. Why? Because radius is perpendicular to the tangent, that you know by theorem 10.1. Okay, so in right angle triangle OTP and ORP, angle OTP and angle ORP is 90 degree. Radius is perpendicular to the tangent. Now OP is and OP is common, so common. OT and OR are radius, so radii. So by right hypotenuse side congruency, triangle OTP and triangle ORP are congruent. Okay, how? This is the right angle, OP is a hypotenuse. Here see, 90 degree opposite side is hypotenuse, so right angle, hypotenuse and one side is radius, so RHS, right hypotenuse side congruency. Triangle OTP is congruent to triangle ORP, therefore by CPCT this PT will be equal to PR. CPCT means corresponding parts of congruence triangles are equal, so PT and PR will be equal. Okay, hence proof. Thank you.